Okay, so now that we got a chance to go over problems that involve graphs, and the one that we went over together, the last video was the limit as x approaches 2 of this function right here, which was f of x. And I basically asked you, well, what is the y value as we approach 2? Well, remember we had approached it from the left and from the right, and we can clearly see that the y value that it approaches from the left and the right is 5, right? And that's what we did in the last video, okay? But what if instead of giving you the graph, I gave you this actual equation here, all right? And now I think this is a perfect time for you to understand, well, why is it that we actually have a hole here again? And the reason why is, well, all we have to do is we have to factor the top. All right, so we factor the numerator, we're going to get x plus 3 and x minus 2. All right, and this is all divided by x minus 2. All right, well, you'll notice here 3 times negative 2 gives me negative 6, and 3 plus negative 2 gives me the positive x right there. All right, so now that it's in full factor form, I think we can kind of hopefully start to see why we have a hole in our equation, in our graph, and that's because we have the same factors on the numerator and the denominator. Whenever we have the same factors in the numerator and denominator, that gives us a hole on the graph at x equals 2. And basically, it begs the question of why can't we just plug in 2? So let's go ahead and try. If we actually try to plug in 2, we're going to get 2 plus 3, well, 2 minus 2, and 2 minus 2. We're going to get 5 times 0 divided by 0. And this is going to be 0 over 0, right? And it doesn't make sense, right? We can't divide 0 into 0 things. That doesn't make any sense. And first of all, we can't even divide by 0. And so we can conclude, right, that we're going to have a hole. All right. And so that's where the hole comes from, by the way. Now, in terms of how does this graph get formed? Well, because we have the same factors top or bottom, we could just cancel it out. And so we're just going to have the limit as x approaches 2 of x plus 3. Okay. And now you could see, well, look at the y-intercept is 3. That's where this line comes from. It comes from the fact that the two factors cancel out. We're just left with x plus 3, a linear equation, all right, with y-intercept of 3, with the hole when x equals 2, our hole is at 5, okay? Now, if you wanted to know what that y value was, well, to know it was at 5, with the equation, all you have to do is take the 2 and plug it in. And we're going to get 2 plus 3, which is 5. Perfect. So now we know, all right, that, well, basically what we had here, that the limit as x approaches 2 did in fact equal 5, and that's verifying it with the equation. So why not take a look at an example, this problem here, which is a little bit more tricky. All right, so I'll go ahead and rewrite it. The limit as x approaches 6, all right. And what I'm going to do is, you see, I look at this last term here and I see that there's an x there. And so basically I want to distribute it out. All right. And so when I distribute that out, I'm going to get parentheses here. This is going to be, well, this multiplied by this first term should give me x to the third. Well, that has to be x squared. Okay. And then this times this should give me negative 12x squared. So it's going to be minus 12x and then plus 36. Okay, all divided by x squared minus 36. Again, x times x squared gives me x to the third. X times negative 12x gives me negative 12x squared. And x times 36 gives me plus 36x, which is basically what we had back over here. But I'm pulling out the x because it's the lowest. We only had that x on that lowest term. And if you look now, this looks like a quadratic function that we can finally factor. All right, so if I factor the top, I'm going to get the limit as x approaches 6. I'm going to get x, and I'm going to get x minus 6 and x minus 6 on the numerator, all divided by x plus 6, x minus 6. Well, now if you look here, right, I couldn't plug in 6 originally because I'm going to get 6 here. 6 minus 6 is 0, and 6 minus 6 is 0 on the top and bottom. We're going to get like the same problem above, 0 divided by 0. But because we have it fully factored, these are the same factors, numerator, denominator, we could just cancel them out. And so now we're going to get the limit as x approaches 6. And now we just have this function right here. And now I can officially plug in 6 into my equation. I can take the 6 and plug it into wherever I see an x. And so I'm going to get the limit as x approaches 6 of 6 times 6 minus 6, all divided by 6 plus 6. Well, I'm going to get 6 times 0, all divided by 12. And if you notice, this is okay. We're going to get 0 divided by 12, which is indeed 0. Okay, the only time we can't get a 0, we can't get it to be defined is when we have a 0 in the denominator. All right, because we can't divide by 0. But this right here is the same thing as 1/12 times 0, right? All I'm doing is taking a division problem and turning it to multiplication, and anything times 0 is just 0. All right. Okay, let's go ahead and look at this one here. This is the same idea as the previous example, except now look here, and the lowest factor is x squared. All right, so I want to pull out an x squared. Okay, well, this is going to be x squared minus 81. And then down below here, well, x to the third is my lowest x, like my lowest term. So I'm going to pull an x to the third out, and I'm going to get x minus 9. Okay. Well, I'm not done just yet because I can still factor the numerator. So I'm going to get the limit as x approaches 9, x squared. And we're going to get, well, this is a perfect of 2 squared, x minus 9, x plus 9, all divided by x minus 9. Okay. And now we could see, oops, I forgot the x to the third here. Now I can see that these cancel out, and I'm going to get the limit as x approaches 9, and I'm going to have x squared times x plus 9, all divided by x to the third. Okay, I can still simplify this further, right? On the top I'm just going to do it very quickly, x times x, and I have x plus 9. Okay, x times x is x squared. I'm just basically showing you how we can simplify this. And we have 3 x's on the bottom because it's x to the third. Well, this cancels and this cancels. So we're just left with 1. So 2 of these cancels with this, and we're just left with 1x. So we're going to be left with, okay, I'll go ahead and do it over here. The limit as x approaches 9 of x plus 9, all divided by x. Well, now I plug in 9 in for x, and I'm going to get 9 plus 9 divided by 9. So I'm going to get 18 divided by 9, which indeed gives me 2. Okay, so it was a pretty lengthy problem, but I obviously went through a lot of steps, right? So we can finally conclude, okay, that the limit as x approaches 9 of x to the fourth minus 81x squared, all divided by x to the fourth minus 9x to the third, is equal to 2. And that's it. Okay. All right, let's look at this problem here. Another problem that can be very challenging, and if there's most likely that you didn't cover this in pre-calculus or algebra 2. So hopefully we can work through these, and it's just a matter of getting practice. And to do these problems, we're going to get kind of, I guess you could say, a little tricky, because we're going to multiply the numerator by 1, and I'm going to show you how we're going to do that. Okay, you can see I'm multiplying everything by 1. You know what, just because of the colors and the way it's looking, I'll go ahead and just rewrite the problem up here. We have the limit as x approaches 0. We have the square root of x plus 3 minus the square root of 3, all divided by x. Now when we go to multiply by 1, what I'm basically going to do is I multiply by the conjugate pair. Since there's a minus sign here, I'm going to multiply the same exact thing but with the plus. And I think you'll understand why I'm going to do that in a second. Okay, now this might look a little strange right now, but just give me a second and we'll work through this together. The reason why we're doing this is because it's the perfect of 2 squares, right? For example, we have x minus 2, x plus 2, where we're going to get x squared. Okay, this is going to be x times 2 plus 2x and minus 2x, well, minus 2x, and then negative 2 times 2 is minus 4. Look what happens in the middle whenever we have the same thing but with the minus and a plus sign. The middle terms cancel out and we'll get left with x squared minus 4, right? And that's essentially why, exactly why we multiply the same exact thing except with a plus sign, so that the middle terms can cancel out. Now you'll look and see, okay, well, we can do this problem. I'm going to write it down right below here. The limit as x approaches 0. Again, you can see I can't just plug in 0 into here because I'm going to get a problem that's dividing by 0, which is not possible. Well, again, this times this, right? The square root times the square root cancel each other out. So we're just going to get x plus 3. And then this times this is going to give me minus 3. Okay, all divided by, again, I don't have to worry about distributing it out perfectly because it's a minus sign here and a plus sign here. The middle terms will cancel out. So all I can do is just multiply this times this and this times that. That was just, again, from this example problem here, right? Just x times x, which is x squared, and 2 times -2, and we get the -4. Okay. All right, well, now these cancel out. Down below, we're going to be left with x, and we still have this square root of x plus 3 plus the square root of 3. All right. So now we finally get the limit as x approaches 0 of x divided by x times the square root of x plus 3 plus the square root of 3. And you'll notice these also cancel out. Therefore, we get the limit as x approaches 0, and we're going to get 1 over the square root of x plus 3 plus the square root of 3. Now we can just plug in 0 into my x, and I get the square root of 3 plus the square root of 3. And so my final answer is 1 over 2 square root of 3. All right, and then that's it. That's basically how I simplify my problem. Okay, take a little bit of work. Again, we'll get some practice with it, all right? And you'll get a chance to do some of those problems. All right, let's go. Okay, so if we look at this problem here, well, we need to find like terms, right? We have this fraction on the top, so I want to just focus on the numerator. We have 1 divided by x minus 1/2, okay? We want to turn this into a fraction. Well, I need to multiply both sides over here. We want to get like terms on the denominator, so x by x, and over here I'm going to multiply 2 and 2, okay? Therefore, on the numerator over here, I'm going to get 2, okay? On the bottom, now we have the same denominator, so 2x. We're going to get 2 minus x, okay? All right, now let's go ahead and rewrite this problem. The limit as x approaches 2, we're going to get 2 minus x divided by 2x, all divided by x minus 2, okay? Now, ideally, we would like to cancel these out, these expressions that we have here, all right? And this 2 minus x, I'm going to get really fancy, and I'm going to rewrite it as negative x minus 2, all divided by 2x divided by x minus 2. Well, why did I do that? Well, if we look here, negative x minus 2, if I multiply the negative across, I get negative x, and I multiply the negative times the negative 2, I get plus 2, and this is just the same thing as 2 minus x, which is what we have right over here, okay? But a reason why I'm basically distributing out a negative is so that the factors look identical to each other, all right? And now all I need to do is just cancel them out. And we're going to get, well, negative 1 over 2x, okay? So last but not least, the limit as x approaches 2 of negative 1 divided by 2x. I take the 2 and plug it in for the x, and I'm going to get negative 1, 2 times 2, which is 4, so negative 1 divided by 4. And this is my final answer. Again, these ones are really tricky, and I don't expect you to fully get them right away. It's just a matter of some practice, all right? So here's another problem. Again, one more time, I'm just going to go over it again. These, again, they're very, very challenging, right? Okay. Now, in this problem here, you might think, okay, I need to multiply by my conjugate pair, right? The square root of x plus 5 and the square root of x plus 5. I told you we always want to do that. Well, I would caution on this for a second. And you could do this and we'll be just fine. But you should notice, okay, that if I take 0 and I just plug it in, right away, everything's perfectly fine. Because look, I plug in 0 minus 5 and the square root of 0 minus 5. Well, 0 minus 5 is negative 5 divided by, well, the square root of 0 is 0, so 0 minus 5, and we just get negative 5 divided by negative 5, which is just 1. So you can see in this problem here, we didn't even have to do anything. We could just plug it in and we get our answer to be 1, okay? If we look over here at this example problem that I showed you over here, okay, we had to do that because if I try to plug in 0 right away, well, I was just going to get 0 on the denominator, and you can't divide anything by 0, okay? All right. I went over kind of everything we learned in class. Hopefully this is helpful for you to understand how to kind of go about doing these problems.